Very good evening, students. Now I want to say about Vogel's approximation for initial basic feasible solution. I am taking here one example problem from textbook, and here we have to take for iteration 1 row differences we have to take. So among these all values in this first row, 10 is the least value and 30 is next least value. So the difference between 30 and 10 is 20. Here we have to take. As the same way, here we have 30 and 40 are the last two least values. So the difference between these two values is 10 we have here, and here the least value is 8 and next least is 20. The difference is 12. In the same way, column differences are here 40 and 10, the difference is 30, and here 30 and 8, the difference is 22, and here 40 and 50, the difference is 10, here 10 and 20, the difference is 10. Among these all differences, 30 is maximum. So select this entire column, and in this the least cost value is 10. So select this cell for maximum allocation. Here we have 5 and 7. The maximum allocation possibility is 5 here. So 5 minus 5 0 and 7 minus 5 is 2. The next iteration we have to detect, or we have to reduce this entire column, because here allocation value 0. So we have to neglect this column for next iteration. Iteration 2 we have W2, W3, W4, and here F1, F2, F3. Thirty, 50, 10, 30, 40, 60, 8, 70, 20, and here capacity is 2, 9, 18, 8, 7, 14. We take some, here we will get 29. These are the requirement values. These are the capacity values. Next, take the row differences in the same way as previous iteration. Here the row difference is 20, and here we have 30, 40. The difference is 10. The minimum value is 8 and 20. Difference is 12. Here column differences, if we take 12, 38. The difference is 12. And here we have 40, 50 means 10, 20, 10. 10 is the difference. So among these all the values, here we have 22 difference, 8 and 30, 22. So this is the maximum value. We have to select this column, and in this 8 is minimum cost value. So select this cell, and the minimum allocation is possible. Maximum allocation is 8 we can allocate. Here 0 will comes, here 10 will comes. So for next iteration W2 will not be there. So iteration 3 I am taking here only W3 and W4 we have. Here we have F1, F2, F3, and here we have 50, 10, 40, 60, 70, 20, and here requirement we can take 7, 14, and here we have 2, 9, 10 are capacity values. 12 plus 9, 21. It is balanced. So row differences, if we take 40 here, and here 20, and here 50, and if we take column differences 40, 50, the difference is 10, 20, 10, the difference is 10. Among all of these, 50 is maximum. So select this row. In these two values, 20 is minimum, So then allocate maximum allocation 10 here, 0 will comes here, 4 will comes. In the next iteration, F3 row will not be there because here allocation value 0 came now. So take W3, W4 and F1, F2 only. W3, W4 and F1 and F2. So here the values are W3 F1 is 50 and 10 and F2 values are 40, 60 and capacity values are 29 and requirement values are 7, 4. So 11 it is balanced. So here we have to take row differences. Row differences, if we take 50 minus 10, the difference is 40 and 40, 60, the difference is 20. And here column differences, if we take 50 minus 40, 10, 60 minus 10, 50 we have here. So we can take this for next allocation. In this column 10 is minimum, so allocate here maximum allocation possibility 2. 0 will comes here, 2 will comes here. So for the next iteration F1 will not be there. W3, W4 we have here and only F2 will be there 40, 60 and here requirement is 10, 50 and availability and capacity will be 9. 7 and 2. So 7 plus 2, 9. It is balanced only. If we allocate among these two, row difference is 20, 40. At 40 we can allocate first 7 here, 0 will comes 2. For next iteration W4, F2 we have here 60 only. The allocation possibility is 2 only. Requirement 2 and capacity 2 we can allocate here 2, 0, 0 will comes. So in this way we got by Vogel's approximation method all the allocations we got now. So those I will show in this table W2, W3, W4 and here we have F1, F2, F3. And here requirement, here capacity. So here we have 7, 9, 18 and here we have 5, 8, 7, 14, 34 is total and here 10, 30, 50, 10 and 70, 30, 40, 60, 48, 70, 20 and the allocations are at 60 we allocated now 2 and at 40 we allocated previously 7 and at 10 we allocated and at 10 we allocated 2 and the previous at 20 we allocated 10. 20 we allocated 10 and at 8 we allocated 8 and at 10 we allocated 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 allocations are possible. So therefore the minimum cost is equal to minimum transportation cost value is equals to 10 into 5 plus 10 into 2 plus 40 into 7 plus 60 into 2 plus 8 into 8 plus 20 into 10. So here 50 plus 20, 70, 70 plus 2, 80, 350, 350 plus 120, 350 plus 120, 470, 470 plus 64, 470 plus 64, 534, 534 plus 200, 734 is the minimum transportation cost we got. This is the initial basic feasible solution for the given problem by using Vogel's approximation.